Hi guys, so today we're going to be looking at Chapter 2, problem number 9, and it's an instantaneous velocity problem. So let's read the problem together. It reads, find the instantaneous velocity of the particle described in figure P2.3 at the following times. And then it gives us the times of 1 second, 3 seconds, 4.5 seconds, and 7.5 seconds. Now it's important to note that these seconds are our givens. 1, 3, 4.5, and 7.5. And they want us to find the instantaneous velocity, which in other words is delta distance over delta time. And what the delta means is the change in. So another way of saying that is the final distance minus the initial distance over the final time minus the initial time. Let's look at section A. At section A, they want us to find the instantaneous velocity at 1 second. So take a look at the graph of figure P2.3. At 1 second, the final distance is 5. The initial distance is 0. Those are our first two pieces of information. The second piece of information is the initial time and the final time. If you take a look at the graph, the initial time is 0 and our final time is 1. Now using some simple algebra, we find that it becomes 5 meters over 1 second, or 5 meters per second. That is the instantaneous velocity at 1 second. So now let's take a look at B, or at 3 seconds. If we take a look at the graph, we notice that the distance it started traveling at, the initial distance, is 10, while the final distance is 5. So we can plug that into our equation. Now if we take a look at the graph again, we find that the initial time it started at was 2 seconds, while the final time was 4 seconds. And we can plug that into our equation. Now with some simple algebra, we see that negative 5 meters divided by 2 seconds will give us our instantaneous velocity, or negative 2.5 meters a second. And that is the instantaneous velocity at 3 seconds. Now we take a look at C. They want to know the instantaneous velocity at 4.5 seconds. So at 4.5 seconds, we see that the distance it started traveling was at 5 meters, and the distance it ended traveling at was 5 meters. And we can plug this into our equation. If we take a look at the time, we notice that it began at 4 seconds and it ended at 5 seconds, where the final time was 5 seconds minus the initial time of 4 seconds. With some basic algebra, we see that we can get 0 divided by 1. And on any good day, we know that that is 0 meters per second. That is the instantaneous velocity at 4.5 seconds. Now let's take a look at D at 7.5 seconds. We see on the graph that the initial distance is at negative 5 meters, while the final distance is at 0 meters. We can plug this in to our equation. We can also see that the time starts at 7 seconds and ends at 8 seconds. we see that it becomes 5 meters over 1 second, or 5 meters a second. That is the instantaneous velocity at 7.5 seconds.